Hey guys, hi, welcome to this session. I hope all of you had an amazing day, all of you enjoyed your day, yeah? Oh, hi guys, hi, wonderful. Oh my god, I can see a lot of students today. That's really great. Super, yes, I had an amazing day as well. I hope all of you guys are fine. Super, I can see a lot of my students there. What are you guys doing here? You don't have batches today? I'm just kidding. Great guys. Awesome to see such a good response for this very important topic. That's really good. Amazing. Yeah, exactly. So once again guys, good evening to all of you and welcome to this session. I hope you guys had an amazing day and your evening is also going on really well. Let's try to make it a bit more interesting by the concept of motion. Now, the reason why I took this particular concept today is basically I've been getting a lot of requests and a lot of inquiries from students and as well as parents to take up this particular concept in particular because a lot of students are facing difficulty regarding one particular topic in this chapter. Now that is not any numerical, that is not any particular concept, but it's actually the graphical representation of motion. Now, a lot of people can argue here that sir, that are relatively easy, correct? But I don't think so. Because if you think about the normal numericals which are really complicated, the only thing which you need to do is to understand the question, visualize the question and then just solve the numerical by applying the formula, correct? But that is not the case for graphical representation. The imagination level or the visuality level in terms of numerical and in terms of graphical representation, it's like this. It's a very huge difference between it. If you cannot imagine the scenario, what is happening, if you cannot visualize the scenario up till here, you will not be able to describe a motion in terms of graphs. And also in terms of examination, 3/4 of this entire chapter is actually graphical representation if you have noticed, correct? You have graphical representation through equations of motion, graphical representation numericals and complicated numericals, not only in your 9th standard but also going on to your 11th standard and plus your JEE mains, correct? So this chapter and this particular topic is actually forms the foundation of this entire concept of motion, kinematics and a lot. So that's why today we are going to deal with such an important topic. Great. Now for people who don't know me, let me give me 2 minutes to give my intro. Okay. So guys, my name is Abhishek. I'm an aerospace engineer and I'm also a master teacher at Vedantu for physics. I handle 9th and 10th standard students and currently more than 500 students are being mentored under me. I'm also the inventor of Rocket Pro course. Learn it, build it and launch it, exactly. Now basically Rocket Pro course is the only online course which is a practical learning course where not only students learn about rocketry and aircrafts and aero modeling, but also they make their own models of rockets. Not only make them, they launch them as the, you can see the code goes, learn it, build it and launch it. They first learn, then they build it and then they launch it by themselves. Starting right from the practical learning till the moment of launches, it keeps on going that way, correct? So yeah, that apart. So as I said, let's start the session with the concept of practical learning. In this particular session, not only will be representing motion in graphical terms, but also will take real life examples so that you guys can relate to it much better. Okay? So always, we start this session with a quote. As all my students know, we always start this session with a quote. The quote for today or for all of you is this: excellence is not being the best. It is actually doing your best. It's a very important quote, guys. Everyone tries to be the best. Everyone tries to beat one another. It's always a competitive life, but that's not it. When you give your best, everyone becomes the best. So always keep that thing in your mind, guys. Now, I thought, why not from the starting itself make your brain ticking? Okay, that bulb inside your brain start getting glowed up. So let's try how we can do that. So I thought why not give it a riddle? A simple riddle related to the chapter motion. A lot of you guys might already know the answer. So all of you who know the answer, shh, don't answer. Okay? For people who know since the live chat, they will read your answer. So don't, if you know it. If you don't know it, give it. Super cool. So the question here is this, a pretty simple question. A man on a flat soccer field kicked a soccer ball 40 feet away. The ball came back immediately at the same speed. No one else and no object have been involved in the entire scenario. The ball didn't even touch anything on its way. How did the man do that? I'll give you exactly 20 seconds to solve this question. 20 seconds. Was the man Superman? No, Superman even can't do that. Was he Ronaldo? No. Messi is also not the right answer. And don't ever take my name also. I'm never a football player. Enjoy though. But yeah. Great. I can see many of you guys giving the correct answer and many of you giving the wrong answer also. Oh, that's interesting. Simple question, guys. Simple question. Final 5 seconds. Come on. You guys can do it. Come on. Yes, exactly. Many of you guys are able to do it. 5, 4, 3, 2, 1. Your time ends right now. Yes. So how did the man do it? It's pretty simple. The man kicked the ball vertically up. So the man kicked the ball vertically up 40 feet away. It came back without even touching anything. It's not necessary that a bird should be there on above 40 feet away kicking the ball down. No, not necessarily. Correct. Great job, guys. Great job. Well done. Well done. On that happy note, let's start this session. So what are we going to do in this particular session? very broadly is this particular step. First of all, let's try to understand what are these graphs or graphical representations we are talking about. Okay. So first we'll start with distance time graphs, which you already know. This chapter might have been already ended in your school and also in our sessions and everywhere else. We have completed this. So let's try to dig deeper into the concept of distance time graph. Then we'll understand what is the entire concept of slope and area under the curve, which is very, very important. And then we'll solve pretty much good level numericals, not only from 9th standard. I'll tell you which standard is coming from later after you solve the problem. And then I will have a small surprise for a lot of you, a very small surprise, a bit of surprise for all of you. That will be, opened up at the middle of the session. Then you have velocity time graphs. Again, which slope and area under the curve will come into the picture. Then again, numericals for that. And also at the end, I'll give you guys a homework. And trust me on this, the homework which I'm going to give, you will be able to solve it within 20 seconds. All the questions after this session. This session will make you capable of that. Got it? Now, I was thinking this velocity time graph concept is actually harder than the distance time graph concept. So why not do the bottoms up approach? Go from the harder to the easier one, so that the easier one becomes way more easier for you. Correct? Because if you understood the harder, easy becomes easy. Way more easy. Correct? And along the way completely, as you can see here, I'll be giving out plenty of tips and tricks to solve this particular concepts. Okay guys? So with that, let's start this session. First thing, I want everyone's attention completely focused here. Do not focus on the chat right now. Focus here. Okay? First question which I want to ask all of you is this. Think about it and tell me, what is the significance of graphical representation? Why do we need it in the first place? Why do we need to learn this? Why do we need to have a brainstorm every day for this? First option, to describe any kind of motion. Option D, to obtain the unknown parameters. Option C, to calculate even a satellite's trajectory space easily. Or all of the above. Yes, I'm pretty sure satellite's trajectory is covered by the same representation through graph. A rocket's presentation, everything is actually discovered through the help of graphs only, because it's pretty easy to understand. I can see a lot of you guys giving me the correct answer. Option D, yeah. Option D, amazing. Well done guys, well done. So let's see what is the answer, and you guys are amazingly correct. It's all of the above. Now look into this. Graphical representations is actually being used even in ISRO, in NASA, ESA, JAXA, wherever aerospace industries are there, from right bottom to the top, everyone uses graphical representation of motion for rockets and satellites. So that much gravity this concept holds. Cool? That much gravity. Now, let me show you guys a relatively harder question, a level 3 question. So level 3 question comes out to be this. A car moves with a speed of 30 kmph for half an hour, 25 kmph for 1 hour, and 40 kmph for the rest of the 2 hours. Calculate the average speed of the car, okay, with the help of graphical representation. Now this is a very, very tricky question, because this you can do it normally also, where average speed is a very complicated concept for a lot of students. I know what is the mistake you guys are going to do, and I've covered this in my previous webinars also. Check that also out. And also, they have made it a bit more complicated by just asking with the help of graphical representation. Now all of you might be thinking, Sir, what is this? How to solve it through graphical way? We have no idea about it. How to find out average speed with the help of graphical presentation? No idea, sir. Many of you guys have idea. Good job. Many of you don't have idea also. That's okay. That's what you're going to learn right now. So exactly after 15 minutes, after you have learned the concept of velocity time graphs, you will be alone be able to solve this. Just in 15 minutes. So I want all of yours complete attention here. Let's try to understand what are we talking about when you talk about a velocity time graph. It's simple. Velocity time graphs is what? When we say velocity time graph, we mean that velocity is in the y-axis, simple, and the time is in x-axis. I believe all of you guys know what is a graph. Correct? You guys know that? Super. Okay, so you have y-axis and x-axis of a graph, and the y-axis is supposed to be velocity in terms of SI units, that is meter per second. It can be in terms of kilometer per hour also, does not matter. Simple, chill, not to worry. What is x-axis? X-axis is always the time. Correct, time in seconds. Now a lot of students have asked me this question, and let me know if you guys know it. Why don't we study time velocity graphs, sir? Why is time never on the y-axis? In the case of distance time graph also, why is time never on the y-axis? Why? Does anyone know the answer for this? A very simple question, a very mathematical question, not a physical question, a mathematical question. Anyone knows the answer for this? Simply sir, it makes it easy. Oh, interesting. No idea? Why is time axis never a y-axis? Why it's always x-axis? Any idea? No idea? Oh, a lot of you have ideas? No ideas. Okay, great. Super. Then let me tell you that first. Because a lot of students have asked me this question before. It's pretty simple, guys. Pretty simple. X-axis is always the axis for an independent variable. What is it? X-axis always an axis for an independent variable. Never forget that. So when you look into velocity and time, which one of them is an independent variable? It is time. Don't you think so? Now you might be thinking, how, sir? How is it independent? Think about this. Velocity, time. An object is moving in time. An object is moving through time. In 10 seconds, it is moving with a velocity of 20 meters per second. Now my question to you is, can you define velocity without the help of time? Can you define velocity without the help of time? No. What does that make velocity? That makes velocity a dependent variable. That makes velocity a dependent variable. On what? On time. And henceforth, time becomes independent because you don't need anything else to actually describe time. Time always goes by itself. You do something or not do something. So that's the reason why we always take time in the x-axis in the case of distance time graph, velocity time graph, acceleration time graph, blah, 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 etc., etc., etc. Correct? So I hope you guys understood that particular part. Now, what is the significance of this velocity time graph? This velocity time graph explains or describes the motion of any object which is moving with a velocity. Simple. Which is moving with a velocity. Now let me show you all those graphs which I have stored for all of you. Look into this particular part. Here, let's focus on the first concept. The first graph. Now this graph is a very simple one. It's not mysterious at all. It is sitting simply, and this is not my favorite at all. And it should not be your favorite at all. I'll tell you which is my favorite among all these graphs. And you also guys tell me which is your favorite among this. Okay. When you look into the first graph, this graph, imagine it starts from 0 and this is some 10. And this is also some 10 seconds. Cool. This is some 10 meters per second. That is some 10 seconds. Now if you look into it very carefully, you notice the object was moving with a velocity of 10 meters per second, sir. And still till 10 seconds, it's moving with the same velocity. What does that mean? That means this is a constant velocity graph. It's a constant velocity graph. Guys, pay attention because identifying graph is the first thing which you need to do. What? Number one thing is to identify the graph. You get plenty of questions related to this particular part, identifying the graph, also to make the graph. So if you can't identify the graph, you cannot make the graph. That is the first trick to understand any kind of a question related to graphical representation. Got it? Identifying the graph. So which graph is this? This is a graph which represents constant velocity. And for a velocity, for an object which is a constant velocity, that velocity graph will be parallel to your time axis. The object, this is the constant velocity. Constant means 10 meter per second continuously. पैदा हुआ 10 meter per second में, मरेगा भी 10 meter per second. Simply of that sort. ठीक है? Now let's focus on the second one. The second one is a bit interesting. Now if you notice, this point will always give your initial velocity. Okay, that particular point will always give your initial velocity. So make a note of that also. This point is your initial velocity and this point will always give your final velocity. Okay, U and V. Now if you notice very clearly, from initial velocity to final velocity, the graph is increasing almost at 45 degrees, if I assume. Correct? Almost at 45 degrees. So we can assume here that it's undergoing a constant acceleration. How do you say that? How can you say that? Because you can notice very clearly, velocity is increasing and it is increasing uniformly. Get your point? It's increasing uniformly. So this kind of graphs we'll call it as constant acceleration or uniformly accelerated motion. What do you call it? Uniformly accelerated motion. A very, very important concept. A lot of questions come from this particular part. Uniformly accelerated motion or a constantly accelerated motion is this particular graph showcased to you. Okay? Because it's linearly increasing, no? Constantly increasing. That means if you somewhere here is the velocity somewhere here is 2 and the time somewhere here is 2 seconds. After 4 seconds, what will be a velocity, guys? After 4 seconds, what will be a velocity? What will be velocity? Exactly correct. Velocity will be 4. Super. Why? Because you can see here that U must be proportional to your time. Constant. U is proportional to your time. Constant. Correct. So it is increasing constantly. So that's the graph, guys. Now notice the third graph. The third graph, if you notice very clearly, it's exactly the opposite. It's exactly the opposite. Now your initial velocity U here is higher and velocity V is obvious. Final velocity V is obviously lesser. So if I consider here that U is equal to 10 and V is equal to you know how much? It should be somewhere about 2, whatever it is. 2, yeah. And the time taken, imagine, is somewhere about 10 seconds. Somewhere about 10 seconds that's taken. My object was moving at a velocity of 10 meter per second. Suddenly the person applied the brakes and the velocity of the object came down to 2 meter per second. Now this kind of a graph is already called as, very good guys, amazing. It is called as retardation or it is called as deacceleration. And what kind of retardation is happening? Negative retardation is happening. Super. Now how can you prove that mathematically? It is pretty simple. Focus here completely. You know the formula for acceleration. A is equal to V minus U by T. Correct? You know the formula for acceleration. A is equal to V minus U by T. So A will be equal to, what is V? V is nothing but 2, sir, minus U is nothing but 10, sir, and T is equal to nothing but 10 again, sir. And when you solve this particular part, you will get A is equal to minus 8 divided by 10, giving you an answer of minus 0.8. I do not care about the value 0.8. What we care about is the negative sign here. If you notice very carefully, it is a negative sign indicating, sir, it is a retardation. It is a negative acceleration, which is nothing but deacceleration. So that's how your graph itself is implying it's a negative acceleration. So even if you didn't know the formula, looking at the graph, you can tell it what kind of a motion it is having. Correct? Super. Now the fourth graph is really important because it is not there in your NCERT textbook, but it comes in your examination. The graph is for objects thrown upwards. Imagine. Let me explain you guys this particular graph very clearly. An object which is thrown upwards. What happens to it? Does it accelerate or does it deaccelerate? I'm not talking about a rocket. First of all, I'm not talking about rocket because rocket is an entirely different scenario. Imagine a ball in your hand and you're throwing it up. Does it accelerate while going up or does it deaccelerate while going up? Exactly correct. It deaccelerates. Correct. Because ultimately it goes up and stops at a point. Correct. If it has to stop, that means it must deaccelerate. Correct? Agreed? Super cool. So imagine you threw it with a velocity of U, initial velocity. You threw it with a velocity of U, and obviously it is deaccelerating. So you must get a negative acceleration here, and hence your velocity drops to final velocity becoming V is equal to 0. Correct? V is equal to 0, touching at time Correct? And this is the point of maximum height. This is the point at maximum height where velocity is 0. Now if you notice very clearly, the graph still goes downward. Correct? What is this negative acceleration downward? What is this thing happening negatively? If you notice very clearly, after it reaches the top position, it starts coming downward. Correct? And this downward motion is considered to be now a negative velocity. Correct? No. Because initially it went upward and we consider it to have a positive velocity. Correct? You consider it as positive. So when it is coming down, it is coming in the opposite direction. Obviously, the upward motion was in upward direction. Now when it is coming down, it is coming in the opposite direction. So we cannot consider it to be a positive velocity. We need to consider it to be a negative velocity. And it is increasing. Velocity went from top to comes down, it is increasing. So it might be giving you a velocity of the same value. Imagine if it is 4 meters per second, this value is also 4 meters per second only. But this 4 meters per second is a negative answer. Negative 4 meters per second. Because it's in the opposite direction. So imagine, I was able to explain this entire concept with the help of just one graph. What happens to a ball when it is thrown up? The entire thing we are able to understand with the help of just one single graph. That's the magic of it. Correct, guys? I hope you guys are able to understand this particular part. Simple, don't worry, we'll go in a bit more detail. So don't worry about it, take it easy, understand it very clearly. Since this is on YouTube, you can replay it however you want, how much ever times you want to get the precise definition again and again. Correct? Now, let's talk about your velocity time graph for this kind of an object. Now, this is my favorite one. This is my favorite one. As I told you in the starting itself, one graph is there for me favorite, and this is that favorite one graph for all of you. I don't know which one is your favorite. I tell you why this is favorite for me. Because this is a one bounce concept. Imagine a ball, throwing it down and you then holding it again. Take a one bounce concept. So you have a ball, you throw it down, it goes and hits the ground, comes on top and you hold it again. A one bounce concept. And we are going to understand the entire one bounce concept with the help of just this one particular graph. Very carefully look into it. Initially, the velocity of the ball was 0. It was in your hand. It was not moving. So it was 0. Then what did you do? You threw it downward. When you threw it downward, the velocity increased. It started increasing gradually, usually, it started increasing in a constant direction. So it increased and it reached to its maximum velocity. It reached to its maximum velocity just before touching the ground. Correct? No. Just before touching the ground, it reached your maximum velocity. At that particular point, what happened? After that, it hit the ground. In that particular moment, the velocity suddenly dropped to 0. Suddenly dropped. As soon as it hit the ground, suddenly the velocity dropped to 0. After that, what happened? It goes upward. And it goes upward with the same velocity with which you threw it down. Okay? Considering that there are no losses. I know many students will be asking, sir, there are losses. How can it be possible? Considering there are no losses, the ball comes back with the same velocity. So the ball is coming back with the same velocity, but obviously in the velocity we need to consider it as negative. Correct? Because it's in the opposite direction right now. So same velocity considered as 4. Here it's also 4. Then what happens? At the point where you hold it, it reaches to the maximum velocity before you go and hold it. Correct? And once you hold it, the velocity again drops down to 0. So this is the entire explanation of this particular one bounce case. That's why it is my favorite. The entire thing, correct? How many things you can explain with the same thing? Our table tennis, match, our cricket match, everything you can explain with the same concept. Correct? Just imagine the gravity. And similarly, you have this concept of irregular motion where velocity is random everywhere. Correct, guys? So this was the entire different types of velocity time graph you may get for your examinations. Very, very important. They will just give you the graph and they will ask you what kind of a motion is this. They can also give you the motion and tell you to plot the graph. We'll be doing similar kind of numericals today, but at a very high complicated level. Cool, guys? So next thing which you need to know, as I told you in the starting itself, that is nothing else but the entire concept. Whatever we have studied, the entire concept is here. If you notice very carefully, imagine someone among you, is moving in his bike. He is moving in his bike and started from the velocity 0. He started moving with a constant velocity. So for a constant velocity or a constant acceleration, you guys know that the graph will be linear. So the graph will be moving linear up to a point. After that, what happened is he got bored in terms of moving slowly. Acceleration was really slow, so he increased the acceleration. When he increased the acceleration, what happened? He suddenly increased the velocity. So this kind of steep slopes, this kind of steep height is corresponding for accelerated quickly. Okay. Then what happened? He's like, nahi, too much of stunt. We did too much of stunt. Let's try to make it a normal steady speed. So what he do? He made the velocity constant. Now the velocity is not moving, is not increasing, not decreasing. Now the person has made the velocity constant. Hence, at that particular moment, no acceleration would happen. So your velocity becomes constant there. Cool? Velocity became constant there. Then after that, he is going to reach his stop. So what did he do? He actually reduced down its velocity, started deaccelerating, applying the brakes, and the brakes came down up to a point when he stopped the vehicle and the velocity became 0 for some time. 0 for some time the velocity became. After that, he started returning back. When he started returning back, now you obviously cannot consider the velocity to be positive because now you're returning back in the opposite direction. So velocity continuously increases but in the negative direction, and again he goes for a steady velocity. While coming back, he's a good boy. While going, he was a very bad boy. So that's the entire concept which you just studied right now with the help of different graphs. We have combined all of it with this particular graph. In your examination, you'll be getting a scenario. They will give you a table and they'll ask you to plot a graph, and this is how the graph is going to look like for most of the cases. Okay? So I hope all of you guys have understood. Give me a quick yes if you have understood, guys. Yeah? Till now, going good? Everything going inside your mind? Nothing going as a bouncer, right? Let me know. Whenever you face a difficulty of this particular sort, after the session, you can always put the doubt in the comments, and also I'll share my email ID and the number so you can ask me your doubts later. Okay? Whenever you guys want, don't worry about it. Take it chill. Relax. Okay. Now going on to the concept of slope of the curve and area under the curve. It's really important to understand this because majority of the questions come from this particular topic of slope of the curve and area under the curve. Let me teach you guys that particular part. Now basically, which kind of a graph is this, guys? You have understood this now, no? Which kind of a graph is this? What is happening here? What kind of velocity time graph is this? Exactly correct. This is the graph for constant velocity. Correct? You can notice it very clearly here that the velocity of the object is 4 meters per second, u is 4 and v is also 4. Continuously, it's a constant velocity. What kind of a graph is this, guys? The second one, what kind of a graph is this? Exactly correct. Super. It is a uniformly accelerated graph or is a constantly accelerated graph. Super, guys. Super. Very nice. Really happy to see this. What kind of a graph is this? Simple one. Exactly the same, uniformly accelerated but in the negative direction. So we'll call this as uniformly deaccelerated graph. Super, guys. Super. Amazing. Deaccelerated graph. Amazing, guys. Super cool. You guys have learned a lot of stuff. Great. Now, let me take the second graph to explain you guys about slope of the curve. What we're going to understand right now, let me tell you guys very clearly. We are going to understand what is slope of the curve. A very important concept. Now in mathematics, I know many of you guys have given me the answer. Well done, guys. Well done, super. What is the slope of the curve in terms of mathematics? In the most simpler terms, slope of the curve means what is the y-axis divided by the x-axis. Simple. In the most common terms, what is this? This is y-axis divided by x-axis, and also it can be stated as y2 minus y1 divided by x2 minus x1 if you are looking for the slope of the curve in specific two regions. Okay, specific two regions if you want. See, imagine if I ask you what is the slope of the curve between this point and this point. So this point becomes your y2, this point becomes your y1. Like, I'll draw this lines here. Okay, this is the line here. So I am asking you what is the slope of the curve between this point A and this point B. So what will you do? From both the points you will draw parallel lines to x-axis and y-axis. Here also, here also. This will become your y2, this will become your y1, and this will become your x2, and this will become your x1. So ultimately what are we doing? We are finding out y-axis by x-axis only, but in a more particular term, more specific term, because the question was very specific. Correct. The question was very specific. That's fine. Now keeping all those things apart, if you notice, for a velocity time graph, if you notice, the slope of the curve is equal to y-axis divided by x-axis. What is y-axis here? The y-axis is velocity. Exactly correct, guys. And what is x-axis here? Time. Now quickly tell me, what is velocity by time? Exactly correct. Oh my god. Super guys. Velocity by time is nothing but acceleration. So what does velocity time graph give you in terms of slope of the curve? It gives you acceleration. Now I give you a very important job. Think about this first curve and tell me what is the acceleration for this curve, guys. What is the acceleration? Super. I can see many of you guys giving the correct answer. Amazing. Exactly correct. The acceleration here should be equal to 0. Why? No slope, sir. Slope is not there. It is a parallel line. If there is a parallel line, it is a 0 slope. So acceleration becomes 0. And that's entirely true because it's a constant velocity. The velocity is constant. If you try to prove it mathematically also with the formula, u is equal to 4, v is equal to 4. So if I apply the formula a is equal to v minus u by t, what will be the answer? 4 minus 4 divided by 15, and your answer will be what? Equal to 0. 4 cancels off. So acceleration is 0. Mathematically proven. Correct. So now when you notice here, you needed to do this much long, mathematical proof to understand this. But once you start understanding the concept of slope of the curve, easy. Looking into the graph, you will tell me, sir, what is the value of slope of the curve? Correct? Super. Amazing, guys. Amazing. I hope all of you guys understood this particular part. Now, since we have understood the slope of the curve, I want you guys to tell me what is the slope of the curve between this point and this point, A and B. Quickly calculate and tell me what is the slope of the curve here. That is, what is the acceleration here with the help of the graph. How will you do it? First, as I told you very clearly, draw lines parallel. Imagine this is at 2, okay? And this is at 5. Similarly, draw it here. 1 and this is 10. Correct. So this becomes your y2 and this becomes your y1 and this becomes your x2 and this becomes your x1. So if you notice very clearly, what is acceleration? y2. Oh, 1 second. Give me 1 second. I think 2. 1 second. Yes. Cool. Okay. So let's try to find the acceleration here. Doesn't matter if it is wrong also. Let's see. If you notice here, what will be the answer? y2 minus y1 divided by x2 minus x1. Now, what is your acceleration here? y2 is nothing but 2. Let's consider this point as 1. Okay. So, 2 minus 1 divided by x2 is 10 minus 5, giving an answer of 2 minus 1, 1 by 5. Correct? That is your acceleration right there. Okay? Cool? Very nice. So you guys, you have understood that particular part of slope of the curve. Now let's try to understand the concept of area under the curve for a velocity time graph. A very important concept, area under the curve. Cool. So let me take a normal graph. I'll take a graph here. Let me take a graph of constant velocity. Simple thing, a constant velocity graph. Imagine this is at 5 and this is your 0 and this becomes your 10 seconds. Simple, not a hard one, a simple one. Now I want to ask you, what is the area under the curve? Whatever curve you get, you find out the area, actual 2D area of that curve, you get the answer. So quickly find out, guys, what is the area under the curve? Simple, it is a rectangle, and rectangle is equal to nothing but length into breadth. And what is length? Length is nothing but 10 into what is breadth? Breadth is nothing but 5, giving an answer of 50 something. Correct, 50 something. Let's hold on to that. Let me ask you guys, this is velocity, y-axis, and this is time in the x-axis. Correct? You guys understood that? Super cool. Awesome. Now, find out what is the displacement. If I ask you, with the help of the graph, find out what is the displacement, how will you do it? It's pretty simple. You know the velocity is 5. You know the time is 10. You will find out the displacement. No, because v is equal to d by t. So your d will be is equal to v into t. How much will you get? 5 into 10 again, giving you an answer of 50 meters. Isn't it? Isn't both of these things related to each other? Don't you think so? Correct? Exactly correct. So the area under the curve for a velocity time graph gives you nothing else but the displacement itself. The displacement itself. Exactly correct. Because and velocity will be nothing but the length or the breadth, and time will be equal to the length or the breadth, and the answer which you are going to get in terms of area under the curve for a velocity is displacement. Kindly make a note of it. So guys, you have clearly understood till now that all the different types of graphs you have understood very clearly, all the different types of velocity time graph you have understood, and you have understood how it explains us a lot of stuff. Then you understood the entire combination. Then we moved on to understand the area under the curve concept and the slope of the curve concept. Slope of the curve for a graph gives you acceleration. Area under the curve gives you displacement. Superb guys. Now, let's solve the problem which I showed you in the starting. After exactly 15 minutes, go for it. The options are given to you. I'll give you exactly not more than 3 minutes to solve this question. Not more than 3 minutes. And I want you guys to draw the graph and solve it graphically. Other way to you guys already know. Correct. Go for it guys. A car moves with a speed of 30 kmph for half an hour, 25 kmph for 1 hour, and 40 kmph for 2 hours. Calculate the average speed of the car with the help of graphical representation. Go for it and tell me what would be the answer. Your 3 minutes have been already started. I think some 2.5 minutes are more left. Go for it guys. Waiting. Super. Many of you guys are pinging me the answers. Okay. It's A, B, C or D. Don't give it a guess. Don't give it a guess. Do it professionally and honestly do it. 3 minutes are there for you. Great. So 2 more minutes left. Still waiting. 2 more minutes left. First step for all of you should be to draw the graph. Okay? That must be the first step. All the details are given to you very clearly. So first draw the graph and the rest of the stuff will be super easy. Okay? Go for it. And again we are talking about average speed, not any other speeds. Great. Many of you guys are still giving me the options. Okay. A. Acha. B. Okay. C is also there. Many of you guys are picking me D also. Interesting. That's amazing guys. That's amazing. That's good enthusiasm. Great job. Okay. 1 more minute left. 1 more minute left. Let's see how much you guys are able to perform. Great. Brilliant guys. Super. Oh, nice. Let me have some water also in between. Otherwise my voice will go. Good job guys. 30 seconds more. And hold on to all of your doubts. Don't worry. After this particular session, you can ask me all your doubts through my contact details which I have been sending you. So don't worry at all. Chill out. Don't worry. 10 more seconds. And परीक्षा की घड़ी आ चुकी है. 5, 4, 3, 2, 1. That's it guys. Time's up. Let's try to solve this question in a very simpler manner with the help of graphical representation. I saw many of you guys giving me the correct answers and many of you guys giving me the wrong answer also. So if I take a percentage, majority were giving me the almost, towards the wrong side. So let me solve it for all of you. Okay? So let's take a new page. New question, so new page. Look into it very carefully. Pay attention. Let's try to draw a graph, and basically we need to draw a graph which is velocity time graph, correct? No doubts about it. Give me 1 second. Let's draw. Oh yeah, we have the graph. Interesting. Okay, so this is your y-axis. Pretty clear. Cool. And let me make the x-axis also. This becomes your x-axis. Almost done. Yay, great. So this is your y-axis for velocity, which is in terms of kilometer per hour, I guess. Yes. Okay. So this will be in terms of kmph. And then you have your x-axis, and this is your time taken, which will be in terms of hours. So no doubts at all. It all starts from 0 always. Let's try to see the question now. A car moves with a speed of 30 kmph for half an hour. So if I name this particular point as 0.5 hours, it moves for 30. So let me name this as 10, 20, 30, and let's name this as 40. Okay, 40 till the top. So you can see very clearly that till 0.5 hours they are saying that it is 30 kmph. For 0.5 hours, the person is driving at a speed of 30 kmph. Then suddenly what happens is 25 kmph for 1 hour. So after 30 kmph, the person drops down the speed to 25 kmph and he moves. So this is my 25 and the person moves for 1 hour. So imagine this is 0.5, this is your 1 hour and this is your 1.5 hours. Correct. So that is the 1 hour from 0.5 to 1.5 hours. So the graph looks like now this. The graph looks like this. Here the velocity is 30 kmph. Here the velocity is 25 kmph. Then after that 2 hours the person drives the car or drives the vehicle at 40 kmph for 2 hours. So if I elongate this particular x-axis, I will get 2 here, 2.5 here. What is 2? 1.5 plus 2 is 3.5 and you will get 3 here and ultimately you will get here 3.5. Correct. So 1.5 plus 2, 3 here, 3.5. Correct. And this goes up to 40 kmph. I hope all of you guys were getting this same graph here. So this goes up to 3.5, a straight line. Okay. This is a straight line, guys. Sorry for my bad drawing skills, but this is your graph here. So till 3.5 it is moving at a velocity of 40. Cool. So this is a graph made. Now let's try to see what are they asking. They are asking calculate the average speed. I'm like, so simple. So simple. What is the average speed formula, guys? First of all, what is the average speed formula, guys? Quickly tell me. Super, amazing, very nice. Exactly. Average speed is given as total distance by total time taken. Total distance by total time taken. We don't know here what is the total distance. Total time taken we know right now from 0 to 3.5 hours is the total time taken for the person to drive the car. That we understood. So total time taken here is nothing but 3.5 hours. But we don't know what is the total distance. How will you find out what is the total distance? By finding out slope of the curve or area under the curve. How will you find it out? Super, exactly, by finding out the area under the curve of the entire region. Correct. So now, since the velocity is varying at each and every position, we cannot find out for the entire area. So what we'll do, we'll find out for this particular area, this particular area, this particular area and get the answer. Let me explain it to all of you. Okay? So let's try to find out what is the distance covered by the person from 0 to 30. Okay? In 30 km per hour, how much the distance covered? So you can see very clearly. How will you find it out? What is the area under the curve? Area under the curve for the first region. Area under the curve for the first region will be how much? Simply length into breadth. It's a rectangle here. So length is nothing but 30 into breadth is nothing but 0.5, giving you an answer of nothing but 15. Correct? So the answer is 15 kilometers. You have got for area 1 as 15 kilometers. Super. Similarly, find it for area number 2. This is for your area number 2 when the velocity is changing to 25. So you can see the length is nothing but 25 and your distance is nothing but 1 hour. So let's name it as 1 and your answer will be 25 kilometers. Correct. From 0.5 to 1.5, what is the time taken? 1 hour. So breadth is 1 hour. So great, guys. So the answer for this becomes 25 kilometers. Cool. Now going for the third region, let me make the graph for this here. So when we make the third region, your third case will be nothing but 40 into 2. 1.5 to 3.5 is 2 hours. Super. And your answer will come out to be 80 kilometers. Correct. So now you have got the entire distance covered with you. Correct. So what is the total distance? The total distance is equal to 15 plus 25 plus 80. Exactly correct. It becomes 120. Correct. 25 plus 15, 40. 40 plus 80 is 120. Exactly, guys. So your answer has come out to be 120 divided by 3.5. And what would be the answer about this? Divide and tell me now. That will become 1200 divided by 35, giving you an answer of almost about some. Let me see. Let me divide it first. So 35, 5 sevens are, sorry, 7 5s are, no, 5 sevens are, and you will have 5 2s are, 5 4s are, 240. So it will become 7 1s are, 7 3s are, point again 4, 34.28. Correct? Exactly. 34.28 you will get, or 36, 34. Let's see whether which one of them is in the options. Let us check. Oh yes, it is 34.28, which is the correct answer. Exactly correct, guys. The answer which just came out for us is 34.28 kmph. Look at this. How easy was it to solve this? With the help of a graph. Now, if you have gone through a numerical way, what would have happened is you need to find out, assume distance from this to this is x. Distance from this to this is y. Distance from this to this is z. Then you now have 3 variables. Trying to solve through the 3 variables and you're going mad completely. Correct? So that becomes a complication, but you solve through graphical representation within 1 page and within 4 lines, your answer is done in just 2 minutes. Correct? So that's how you solve it, guys. And now for the surprise which I was saying, this is not a question from 9th standard. This is a question from 11th standard. Also, this kind of questions come in your IAS examinations. Many of you guys will be aspiring for IAS questions, IAS examinations, for the civil service examination. This kind of question comes in there. The 9th standard question coming there, also in 11th, also in IAS, also in JEE. So I hope all of you guys have understood this particular part. So you must be really proud and very good, guys. People who gave me the answer as option C got it right. So now going for the bigger surprise. The bigger surprise is this. One second. The bigger surprise is basically, where is it? Oh yes, the bigger surprise is here. Vedantu actually is launching a course. Okay, let me take you to this particular link. I want everyone to make a note of this particular link, then I'll explain it. The link is https://vdnt.in/motion9. Okay, motion 9. So that is your link. I want everyone to take a note right now quickly. I'll give you exactly 5 seconds to do it. Okay, 5, 4, 3, 2, 1. Now once you go onto that link, you will find out that Vedantu has launching a course particularly on motions, where similar to this particular webinar, how we went so deep into the entire concept of velocity time graph and did one of the numericals which is of that particular highest level. The same thing we'll be doing here at Vedantu as a course. We'll go really deep in all the kinds of concepts present in the motion chapter, and then we'll go deep in the concepts of numericals. You will be understanding from A to Z concept of numericals in this particular course, which is just for 6 hours completing the entire chapter of motion. Okay? So that's what we'll be doing, and I'll be personally handling it. Yes, I'll be personally handling the entire course. And in this course, as you can see, you'll be learning the introduction of motion along a straight line. Then we'll go on to the concept of what is speed, velocity and acceleration, plus the distance and displacement concept. And there are plenty of numericals which I am planning to take for distance and displacement concepts, because those numericals come out to be a pretty much harder stuff for a lot of students. You guys might also be facing the thing. And you already know how we understand the applications of graphical representation, correct? Exactly. And then we'll start deriving the equations of motion, a very important part, and also the numericals. I'll give you 2 ways to derive this particular equations of motions in a different scenario. Okay? And then we'll go on for obviously uniform circular motion. So that all we'll be covering. And what is the benefit of this Vedantu sessions would be, it's going to be live classes, obviously by me, and you will get very in-depth theory and numericals. Also, I'll be sharing you guys assignments and tests which will be having a lot of questions, like a question bank related to very high level numericals, so that you guys can solve it and master all the concepts. And also we'll be connected through a WhatsApp group 24/7, so you guys can actually ask me any kind of a doubts between any point of time in a day. Okay? So that's what we guys are going to do. And apart from that, let me tell you, the course is starting from exactly 3rd of August. We are starting this particular the session, that is 3rd of August. And right now, especially for all of you, we have reduced down the price up to a lightning deal of just 600 rupees. Correct? Only 600 rupees, that is 599. And I really truly believe that all of you guys would be taking up this course. And also, this lightning deal is only for the rest of the 4 hours, which is now ongoing. As you can see, only 3 hours and 17 minutes is left for the rest of the part. So right starting from now, you have 3 more hours. So 7 to 10 o'clock. By the time 10 o'clock, this lightning deal will be done, and then the course price will be 999. So specially for all of you, this has been brought down to 599, guys. So enroll now as soon as possible. Do that. Okay? Now since we have completed this particular part, let's go on and have some fun. Let me give you guys one more question related to velocity time graph. Okay? Giving you one more question, guys. I want all of you guys to solve it very clearly. This is a kind of a complicated problem. I want you guys to read it, draw the graph and solve it. I'll give you exactly 2 minutes to solve this. This does not take much time. Exactly 2 minutes. And this is also 11th standard numerical. So go for it, guys. 11th standard numerical. Go for it. Come on. Quickly. Okay. Great. I hope that you guys are making your graphs right now. Do not give a guess. Try to give your best right now. Don't give a guess. Good? Okay. Amazing. Super cool, guys. Super cool. Keep going. Keep going. Great. Great. I can see good response. Good going. Good going. A, B, C, and D, guys. Go for it. Go for the options. Just 1 more minute left. Just 1 more minute. Go for it quickly. Okay. Good. Okay. 30 more seconds. Going to end. Actually 25. Actually 25 more seconds. Come on, guys. Quickly. परीक्षा की घड़ी आ चुकी है. Give your best. 15 more seconds. And your countdown starts now. 10, 9, 8. Everyone, give me the right option. 5, 4, 3, 2, 1. The time's up. The time's up, guys. I could see many of you guys giving me the correct answer. Amazing job, guys. Amazing job. Amazing job. Let's try to solve this. First of all, the thing which you needed to do right now is utilize this velocity table and this time table to actually give you the graph. Correct? And if you have made your graph properly, the graph should look like this. Correct? Is it looking like this? Everyone? Yes or no? Yeah, it is looking like amazing. Super. Good job. Exactly. At 0, time is 0. At 5 seconds, the velocity is 10. At 10 seconds, the velocity is 20. At 15 seconds, the velocity is 30. So let's match it up. 0, 0, 5 seconds, 10, 10 seconds, 20, 15 seconds, 30. So it's going on way. And while coming back also the same thing which we have got. So when you plot the graph, this looks like basically like a triangle. So let's read what is the first question. The first question says, calculate the acceleration during 0 to 15 seconds. I'm like, come on. You know that for a velocity time graph, the acceleration is the slope of the curve. Correct? So slope of the curve of what? 0 to 15 seconds. So these are your 2 points. These are your 2 points. This point A and this as point B. And apparently this slope of the curve is nothing but a constant accelerated, right? Constantly accelerated. How will you find that constant acceleration here? Velocity by time. Velocity here is nothing. We need to find out velocity by time. So velocity here is nothing but 30. Correct? Into time is nothing but 15. Oh, not into time. My mistake. My mistake, guys. My mistake. So acceleration is going to be y-axis divided by x-axis. Correct? Y-axis divided by x-axis. What is your y-axis from 0 to 15? Y-axis is 30. X-axis is 15. What is your acceleration? 2 meter per second square, sir. Exactly. Super. Exactly correct. Super. Now let's read the second question. Second question states, calculate the acceleration during last 15 seconds. In the last 15 seconds, if you notice, if I consider this point C, in the last 15 seconds, we are getting a negative acceleration, but also of the same magnitude. Correct? No, because both of them are constant. It's a perfect triangle. So the acceleration, it went upward, must have the same acceleration while it came downward. So obviously, you can directly write down, closing your eyes, that your acceleration must be equal to minus 2 meter per second square. If you want, you can prove it mathematically also. Look into it. Y-axis is again 30, x-axis again 15. Correct. But only difference is it's a negative slope. So you need to consider it as negative answer. Simple. Got it? Let's try to find out the third equation. The question is calculate the total distance. I'm like, come on. So easy question. Calculate the total distance, guys. This is a velocity time graph. So the area under the curve will give you your displacement or distance. Correct? So what is the answer? What is the area under the curve? This is a triangle. So triangle's area is A is equal to half into base into height, and which is half into base is nothing but 30 into height is nothing but again 30, giving you the answer of 900. Correct? 900 divided by 2. Super. And your answer is supposed to be 450 meters is your total distance or the displacement. And there is your 3-mark problem solved in just 3 lines and also in just 2 minutes. Great job, guys. Super. Amazing. Cool. Let's do one more problem. Since we have a small amount of time left. Before doing this problem, I think we should take the distance time concept, because distance time graph we have not covered it up. So we'll just quickly run through distance time graph, because velocity time graph you guys have understood very clearly. So I'll just focus on the concept here of slope of the curve and area of the curve for a distance time graph. Okay. So let me focus here very clearly for this particular part. I think I showed you the answer also, right? Yeah, the correct answer is O. So this answer was not there. Did it? 1 second. Oh my god. Okay, it's my mistake, guys. I suppose the options were not there for this question. 30 divided by 20 will give you 2, and I suppose 15 was there. It's my mistake. It's definitely my mistake. But I suppose you guys have got 2. Correct. It's definitely my mistake. My mistake, guys, for the options part. But I believe that you guys have got 2 meters per second square right down there. Now let's focus on the distance time graph concept. I want everyone to focus here. Okay. So where is it? Yes, distance time graph. Okay. 1 second. Okay. So when you have distance time graph, it's similar to velocity time graph. Nothing much difference. Only difference is the y-axis becomes the distance, and now you're describing the motion of an object in terms of distance and time. Simple. Okay. Now talking about the slope of the curve, pretty simple. Correct. If you talk about slope of the curve, the mathematical formula remains the same. Y-axis divided by x-axis only. So if you have slope of the curve, that is y-axis divided by x-axis for a distance time graph, listen, it's simple. Y-axis is distance divided by time. What will it give you? It will give you it will give you velocity. Amazingly correct. Super. Let's talk about area under the curve now. When you talk about area under the curve, what will distance time graph give you? Distance time graph, area under the curve will give you nothing. So basically for a distance time graph, they don't ask you anything related to area under the curve. Because what is area under the curve? It's nothing but distance into time. Is it? Correct? No, distance in time will you get? Area under the curve. What is distance into time? Any idea? I also have no idea what is distance into time. Correct. So that particular concept will not come into your head. So only thing which will come for distance time graph is basically the slope of the curve. So just remember the slope of the curve for distance time graph, you will get the answer for it. Now let me explain you the different variations of slope of the curve, different slopes we can get for distance time graph, as the same we understood of velocity time graph. If you notice here very clearly, starting right from 0, if you get a steep line, you guys know very clearly that it's a accelerated motion. You know that for velocity time graph, steep line means accelerated motion. Here it means accelerated velocity. Velocity is increasing suddenly. So it's basically nothing but an accelerated motion. But it's increasing suddenly, but it's also increasing steadily. Okay? So that's how it is shown there. But if you notice the second graph, the pink one, this is making an exact 45 degrees almost. So that is your constant velocity. Correct? Constant velocity. You guys know that. It's a uniform velocity graph. Super. Constant velocity. Correct. If for this particular part, if I try to make up the velocity time graph, I'll get constant velocity. Straight line. Constant velocity. And at the same point, from this point to this point, if you notice very clearly, your object is being stationary. Why? If I pull this back to y-axis, if I take this as 10 meters, distance is 10 meters throughout the time. That means my object is stationary. So guys, remember here, all the graphs which are parallel to the time axis for a distance time graph, that means the body is at rest. And this is a very important question for all of you in your 9th standard and also in terms of your 11th standard. Please keep that in your mind. Very important thing. Now if you notice here very carefully, the distance is decreasing with the time. What is it? Velocity is in the negative direction or the velocity is decreasing. Simple. Very simple. And if you're looking at this curve, this kind of curve is called as a positive curve. Okay, this kind of curve is called as a positive curve because it's moving or increasing in the positive direction, and this kind of curve comes when your velocity increases gradually. Slowly it increases. So that's how distance time graph looks like for various scenarios. Now I've already told you what does the slope of the curve indicate. So let's try to do a problem here on terms of distance time graph. I hope all of you guys remember the story of the tortoise and the rabbit. Correct? So if I just give you a scenario to draw a graph for this particular concept, how would the graph look like, guys? How would the graph look like? Come on. How does the graph look like? For both the tortoise and the rabbit, I'll give you exactly 1 minute to do it. Think about the story. I hope all of you guys have heard the story when both rabbit and tortoise started running. They both ran, the rabbit ran very fast and the tortoise was running very slowly. Correct? Obviously it's a tortoise, so that's why it was running really slowly. And one moment rabbit got really far away and he thought, let's take some rest. So he started taking some rest at a position, and meanwhile during that time the tortoise overcome him, surpassed him and won the race. Correct? So I hope you guys remember this particular part. Yeah? 30 more seconds to make the graph. Just 30 more seconds. Go for it. And I'll do one thing, guys. If you guys agree to it, we'll take one more webinar very soon related to the concept of distance time graph if you want it. Because you have noticed right now the velocity time graphs are really crucial. So if you guys want it, let me know to take a different webinar for distance time graph, specifically higher level numericals. You guys want it? Yeah, great. Please let me know that. Okay, cool. So your time's up, guys. Your time's up. If your graph is correct, it must look like this. A distance time graph. Correct? Simple, a distance time graph for tortoise and a rabbit. If you notice here, there's a distance. Imagine any distance. For example, the entire distance is from 0 to 2700 meters. That is 0 to 27 kilometers. 2.7 kilometers, not 27. 2.7 kilometers is the entire distance both the tortoise had to run. Okay? And this is, the green color is for the tortoise. Now tortoise is not increasing its velocity, neither decreasing. It is moving with a constant acceleration. It's increasing its velocity constantly. So if you notice very clearly, the graph is at a constant velocity. It's increasing gradually. It didn't even take rest. Correct? It didn't even take rest. But when we talk about a rabbit, the rabbit after the tortoise even walked off, it was still standing there. For some 5 to 10 minutes, it was just standing there. It was like, yeah, let it walk. Anyways, I'll win. So that attitude made him wait for 2 long minutes. After that, he ran suddenly. So when he runs suddenly, the acceleration becomes increasing suddenly, right? So the acceleration goes up suddenly, and then after one time he has crossed the tortoise at this particular point. At point A, since he has crossed tortoise at that particular point, he takes some rest after going very far away. Takes some rest again. Okay? And meanwhile he's taking rest. At point B, the tortoise has crossed him. And the rabbit is still taking rest till point C. And at point C, the tortoise has almost reached the final position. And at the end, what happens? The tortoise has to cover only this much distance, and when rabbit wakes up, he has to cover this much amount of distance at this velocity. And by that time, what happens? In 15 minutes, tortoise has reached, but in almost about 17 minutes, Mr. Rabbit reached. So 2 minutes faster than rabbit, tortoise reached. Correct? So that's the story, guys. And this is how we explain the entire story with the help of a graph, basically. Great? Super. Now as I promised to all of you, I'll be giving you guys a homework question. So I want all of you guys to make a note of this particular question right now here. Yeah. So that's the homework question for all of you. And what I want you guys to do it, after you find out all the answers, 1, 2, 3, 4 and 5, I want you to write down 1, answer 2, answer 3, answer 4, answer 5, answer, and put all this answer combined into the comments below on this particular video. Let me see who gives me the answer correct first. All the answers correct, the first. I'll be replying to each and every comment, and I'll be explaining you also where you guys have gone wrong in this kind of question. Okay? It's a very crucial question which has come plenty of times in your 9th standard examination. So guys, I want you guys to be perfect. Take some time and do it. Cool? So all your answers must be in your comment below. Also, if you guys have any doubts related to any particular part in this particular chapter, you guys can always email me the question or the answer. You guys want to discuss me anything, you guys want me to tell me sir, session went really good, please let me know. Also you can tell me on WhatsApp. This is my WhatsApp number. You can also do that if you have any doubts related to any kind of questions in terms of motion chapter. You can always do that, guys, but I'm still waiting for this particular answer in the comments below. I'm still waiting for it. So let me see. And more probably I'll give you exactly 24 hours to solve this, not more than that. Just 24 hours to solve this particular numerical, not more than that. I'll not accept any answers after 24 hours. I'm just kidding. Keep doing it. Keep working out, guys. And also I believe that all of you guys have noted on the link for the course, correct? I'll write it down again. It's https://vdnt.in. I remember it. Oh god, it's motion 9. Okay, that's the entire link. I hope all of you guys have made a note for that and for this question also. So with that, guys, I believe all of you guys enjoyed this session. Yeah, did you guys enjoy the session? Thank you guys. Thank you. Thanks a lot. Thanks a lot. And also please let me know which other topic you want me to take in the next video. Put down in the comments below. If the majority is saying me the same answer, we'll go for it. Okay? So with that, guys, we'll say thank you and bye bye. Have a nice evening. Good night, guys. Great. Bye.